Hi folks, this is Daniel Ritchie, the developer of Howler. Tonight I'll be doing something a little bit different. I'm working with Lightwave 3D, and I'm going to create a shader node that will allow me to control the surface roughness of a Lambert surface using a control that is on screen, and it's represented by this little triangle here. Let's see, A to zoom up on it. It says control surface scattering. And I'm just going to briefly go over some of the techniques that we use here. Not going to be a full-blown tutorial, but just basically by moving this triangle up and down, I am able to control the surface roughness, and it does this by jittering the surface normals and plugging that back into the surface shader. And I'll show you what this network looks like. If you go into the surface editor and click on edit nodes and make sure that checkbox is on, you'll see the node editor. And I've created a couple of custom tools here with I believe it's called the compound tool, which basically lets you encapsulate a whole set of these nodes in a simplified form. For example, I created a one called random normal, one called lerp normal, that's linear interpolate between two different normals based on a specific value. In this case, the value is coming from the world position of that triangle object I had over there that's controlling the surface roughness. It's reading the Y value from that. I've limited this so it can only travel on the Y by turning off the X and Z checkboxes and going into the motion panel and setting a limit for the Y motion on that. Click M on the keyboard to get to the motion panel. Alright, so this is the part, the item info is, if you click on it, it shows that I'm linked to the control scattering item, which is what that triangle is called. The world position is fed into this vector to scalar routine, which converts a vector, meaning a set of three values, into a single value. If you click on that, you'll see that it's just the Y channel that we're using. And that is fed into this linear interpolate between two normals function, the blend value. It's a value between 0 and 1. If it's 0, it'll be completely blended out, and if it's 1, it'll be completely blended to the other value. Now what we're blending is the original normal from the surface that's coming from the object. That's the direction that the surface is facing, which is how shading is calculated. And we're also creating a new normal, which is a random normal, which is basically we create a random vector and normalize it. Basically, I'll show you what that looks like in the shading. In this compound node, we take the input, which is the world spot. That means the position in world space where the surface lies. I think we multiply it by a ridiculously large value to get a random seed, which lets us create a random value. We split this into three vectors. The vector to scalar function lets us split out the X channel, the Y channel, and the Z channel, and then we feed these into this random scalar, which creates a random value between a minimum and a maximum. I believe it's -1 to 1. Let me click on that. Yes, -1 to 1, and that will be basically a random value between 0 and 1. And it's fed back into make vector, which makes a vector from three scalar values, and that's fed into normalize. That normalizes the vector, and that's just output. So now we have a new normal, which is basically a random direction in space, and it's basically a normal that would be pointing in any direction, not necessarily any relationship to the actual geometry. So that by itself might be kind of chaotic looking, which is why we put that lerp, linear interpolate, between two different normals. It interpolates between this random one we made and the original. That way, we are able to blend between a completely random normal, and which is what you see there. It's completely random, pointing in any direction. It completely flattens this out because there's no directionality to it anymore, other than random values. If you stop halfway, you get sort of a somewhat random and somewhat shaded look. And if you go all the way up, you'll get the original, completely smooth-looking original normal. This is a good way to create a surface that is flatter, looking like sand might have a very random look to it, or concrete, or well, not feeling very imaginative right now, but you get the idea. Surfaces that are very that diffuse light a lot more than a regular surface would, like a metal surface wouldn't diffuse light like a sandy or a plaster or some other surface that diffuses light because it has a very rough, porous surface. Okay, once we've created these two, blended between these two normals, we simply feed that normal back into the surface, and that becomes the new normal for the surface, which is then how the surface is calculated. So that was just a quick introduction to working with nodes in Lightwave. Hope this has been a fun break from working with Howler, which we will continue to develop over the next few days and weeks. Version 9.5 is coming out soon, which will include some very exciting features for working with 3D especially. There will be some improvements to the 3D designer for creating landscapes. There will be a very cool cloud generating. In fact, if I can find it, I'll bring up very quickly a demonstration of that. And or not, doesn't seem to want to come up. Okay, so talk to you later. Hope you enjoyed this this introduction to nodes and layout, and talk to you later.